Welcome everyone. Today we will speak about relationships within triangles. So mister, what meaning of relationships within triangles? So today we will speak about all lines crossing this triangle. So we found lines bisect the base or bisect the sides. Some lines make bisect the vertex or bisect the angles. Sometimes we found lines perpendicular and bisect the sides. And sometimes we found bisect the vertex and bisect the sides again. Okay, so we speak about all more lines, and we know that what's the difference between them and what its names. Okay, so give me attention here because it's very important for you. Okay, so today we're starting with using perpendicular and bisector. So mister, what meaning of perpendicular and bisector sides? So the perpendicular and the bisector sides, it's segment that is perpendicular to and bisects the segment. Mister, what meaning of that? So if you have line segment like that here, okay, and this line is perpendicular to it and bisect it. So this line we call it as perpendicular bisector. Okay, so the red line here we call it as perpendicular bisector. Okay, the theorem: if a point is on perpendicular bisector of a segment, then is equidistant from the ending points of the segment. What meaning of that? So mister, if I have point like that here, okay, so this point which belongs to the line is perpendicular and bisects the segment. So the distance from this point to the two terminal point, like that here and here, yes, it's equal. Okay, so if I have any point else, mister, yes, if you put any point with this line, okay, so and connect it with two terminal points, two ending points here, the side will be equal. Okay, the blue side here equals the other blue side here. Okay, so mister, this little line we'll call it again as axis of symmetry. So axis of symmetry, what it's do, mister? It is bisect the segment and perpendicular it. Okay, any point belonging to axis of symmetry, it has equal distance between the two terminal points or two ending points. Okay, don't forget that. It's very notes. Again. I can give you example about that. So this line here, the red line here, it is perpendicular to the base here. So I have point here, point belonging to the side. So the line segment here, this blue line here, is 5 centimeter. So the other will be what? Be 5 centimeter. Okay. So again, I will speak about something else. Okay. So I found that if I say the triangle here, A, B, C, and the point here is D. That's the point here of intersection. Yes, wonderful. So mister, I found here this triangle A, B, C. Point of intersection of axis of symmetry is here is D. Okay, so mister, can I say triangle A, B, D congruent with triangle A, C, D? Does the triangle here are congruent or no? Think about that. I give you time. Tell me congruent or no, and give me note about that. I'm waiting. Yes, this triangle here is congruent. Why, mister? Because I have right angle here. Okay, it is ADB. This right angle here. Okay, I can put it blue line on it. Okay, the slight angle here Okay, so if I want to speak about perpendicular bisector, don't forget that. Okay, so that drawing down here, the green triangle here, we will find that each line here, it's B line, N line, and M line. Okay, the three lines here, perpendicular and bisector, is the basis of triangle or the sides of triangle. Okay, so I found here B. Okay, that's B here, it's perpendicular and bisect perpendicular on AB and bisect AB. And I found in here it's perpendicular on BC and bisect BC. Found M here, it's perpendicular on AC and bisect AC. So we found that the three lines make intersect at a point. Okay, this point we call it as what? This point. I put highlighter for it to see it again. Okay, this point we call it as what? That's point of intersection, okay, or perpendicular bisector of triangle, okay, or point of concurrent of perpendicular bisector. So this point we call it as circumcenter. Okay, so what meaning of circumcenter, mister? The circumcenter point, that's point of intersect of perpendicular bisector in the triangle. Oh wow, perpendicular bisector? Yes. So in the other shape here with red circle, okay, we found that the point here, I will put highlighter to see it again. Okay, wait. This point, yes, that's circumcenter. So, mister, what meaning of circumcenter? It's a point of intersection of perpendicular bisector. So, mister, again, this point, if I want to draw the circle, okay, crossing with the vertices of the triangle, its center will be the circumcenter here. Oh, wow. The circumcenter here? Yes. Okay, so it's point of center of drawing a circle crossing with the vertices of triangle. Okay, don't forget about that. Okay, so this triangle I can cross with the circle because with its vertices, its center is circumcenter. Okay, don't forget that. Mister, what next? Oh wow, angle bisector of triangle. From its name, angle, it's meaning angle, bisector. So I found line bisects angle. Okay. So, angle bisector, it's ray with bisects angle. So, if I have here, this my triangle here, sorry, this angle here, and I make lines bisect the angle. Don't forget that. Angle bisector theorem, if a point on the angle bisector, then the equidistance from the sides of two angles. So, mister again, so if I found point like that here on the red line here, so the distance between this point and the perpendicular, if I put line perpendicular to its sides of angle, so it is the distance will be equal. Okay, so now I know that what this red line, it's axisymmetry. No, it is not axisymmetry, but it is angle bisector. So, mister, what meaning of angle bisector again? It is a line bisects the angle to two equal parts. Okay, so, mister, again, if I found point belong to axisymmetry, I'm sorry, not axisymmetry, bisector angle, okay, the point here will be perpendicular on the side, and other side it's perpendicular again. So the two distance from the two lines to the sides are equal. So I will give you example. If the blue line equal 5, so what about the blue other line? We will see that. if the blue line is equal 5 centimeter, we will found the other line will be 5 centimeter. Okay, the converse of the theorem. Okay, so if a point of equal distance from the sides of an angle, then it is on the angle bisector. Okay, next, angle bisector again. Okay, concurrency of angles of angle bisectors of a triangle. So if I have something like that here, that's my triangle here, and this line is bisects the angle. Okay, and this again bisects the angle, so make the two angles are equal like that. It's a bisector here for angle, makes the two angles are equal here like that. Okay, and the last one, it's bisects the angle again. So the three bisectors intersect at one point. This point we call it as in center. Oh wow! Don't forget that again. We'll make revision about what we talk. Yes, perpendicular bisector. Okay, this intersect at a point we call it as circumcenter. Why, Mr. Circumcenter? Because I can draw the circle, its center is this point, okay, and the circle crosses the vertices of triangle, okay. So, Mr. The circumcenter come with what? Perpendicular bisector. What about angle bisector? It is in center. It is what? In center. In center. Bisector in center. Okay. Angle bisector in center. Okay. Angle bisector in center. Okay. The point of concurrency, okay, let's read the definition of it. Point of concurrency of the angle of bisector of a triangle. If the circle was inscribed in a triangle, okay, so in center would be also be center of the circle. Mr. What meaning of the last sentence? Can you tell me? Yes, I will tell you. Okay. So I found here the point of intersection of bisector, okay. It will be center of the circle crossing with the sides of triangle from inside the triangle like that here. Okay, this here, yes, that's radius here, radius, yes, and the circle is touching the sides of triangle. You will find that medians and altitudes. So, Mister, what meaning of median? Okay, oh wow. If you want to speak about median, we'll find more things about median. Okay, in the next slideshow, I will explain it carefully. Don't worry about it. Okay. So now, median. Now, what meaning of median for first? Okay. So it's segment that connect a vertex to midpoint of the sides of triangle. Okay. So it's segment that connects the vertex to the midpoint of side triangle. Mister, I can't understand anything. Can you explain what meaning of median again? Yes. Look at this triangle here. I found triangle here. So, if I found line coming from the vertex of triangle to midpoint, okay, in the opposite side of the vertex. So this line we call it as median. Okay. Now, you understand what meaning of median? Yes, I think. So what meaning of median again? It is a line coming from the vertex to the midpoint to its opposite side. Okay, so a line from vertex and the midpoint, yes. It's connected from vertex and the midpoint, yes. So I will ask about that. How many medians in triangle? Oh wow. Do you remember that? Yes, I think. So any triangle has 3 medians. Okay. Why? Why any triangle has 3 medians? Why not 4, 3, 2, 1, 0? Why 3? I will tell you. Because the triangle has 3 vertices and has 3 sides, and each side has just 1 midpoint. So 3 vertices, that's meaning 3 medians, or 3 midpoints, each point on a side, so I have 3 sides, so I have 3 medians again. So Mr. again, this median again, and this other median, okay? So median, what meaning of median? Median is line segment connected from vertex and the midpoint on its opposite side, okay? Again, it is line segment connected from vertex and the midpoint in its opposite side, okay? Again, the point of intersection of median, we call it as centroid, okay? Don't forget that. Point of concurrency of median, okay? That's what meaning of concurrency, Mr. Concurrency is meaning of intersection of medians. Point of intersection. The point of concurrency is called centroid, okay? The centroid here, what meaning of centroid? It is point of intersection of medians. Oh wow, Mister. Today we take the name of 3 points, different lines, okay? Let's make a revision about that quickly, please. Okay. The first one, point of intersection perpendicular and bisector. We call it as circumcenter. Point of intersection of bisector angle, okay, or angle bisectors. We call it as in center. Yes, wonderful. Okay. So the point of intersection of median, we call it as what? Centroid. Don't forget that. Okay. So, Mister, centroid, it is a balance point. Okay. Wow. What meaning of balance? It is a point that divided the median to ratio. Okay. What meaning of ratio, Mister? Okay. Ratio. It's divided ratio from the base. It's 1 to 2. Okay. That's big balance. Okay. From base 1 to the side 2. I will write it for you now. Okay. Wait. Centroid, it is balance point because it's divided again the median to ratio. It's 1 to 2. Mister, what meaning of 1 to 2? I can't understand. So the length from the point here, I can write the name for points now like that here. I found here triangle ABC, okay? So AD is median, okay? Because it comes vertex and midpoint D here. So M here is point of concurrent of medians, we call it as centroid of medians, yes? So I found the centroid is a balance point, this meaning the ratio would be 1 to 2. So Master, what meaning of that? So if I have length of MD, it's equal 5 centimeter. What about ME? Oh wow, ME must be its double because the ratio is 1 to 2. So if you take 1, I will take 2. If you take 2, I take 4. If you take 5, I take 10. If I take 20, I take 40. So I take the double for you. Okay? So AM takes the double of MD. So if MD is equal 5. So what about MA? So MA is equal 10. Okay? Do you understand that now? Makes I think? Okay, so I will ask again. Ready? 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 Yes, let's take that. If I have AM, it's equal 8. What about MD? Now we'll speak about median. Okay, so medians of triangle. Let's speak about it carefully. So, Mister, this triangle ABC. If I found here, D here is midpoint. So D midpoint of BC. So AD is median. So it's a line connected from the vertex and the midpoint. So as we speak about it before, okay? So it is what? AD is what? Yes, it is median. Wonderful. So median of triangle is a line segment connected from vertex to the midpoint of its opposite side. Don't forget that. Let's speak about it carefully again. Medians of triangle. Definition. Oh wow, what meaning of median? Yes, that's correct. So median of triangle, it's a line segment which joining from any vertex of a triangle with a midpoint of its opposite side. So Mr. like that here, again, so AD is what? Is median. So D here is midpoint of CV, so AD is median of triangle. So that is median here. Okay, wonderful. So I will speak about the medians. Okay, so I said that before. How many medians in triangle? Yes, that's correct. 3 medians. Because a triangle has 3 vertices, so each vertex had just one line segment for it, so it has 3 medians. Or I have each side had just one midpoint, so I have one midpoint on each side, so each side has one median, so has 3 medians triangle. Let's see that to understand it. So from B to E here, E is midpoint, so BE is median. And here from C to F, CF here is median again, because F here is midpoint. So mister, I found here AD is median. What happened here? If I do that and that, oh wow, the triangle had 3 medians. The 3 medians make intersect at one point. Do you remember that or no? Yes, we remember that. Okay, so point of concurrent of medians, that's we call it as what? Who can tell me? Call it as what? Yes, centroid. Yes, centroid of medians. Okay, so this point M we call it as centroid of median. So any triangle has 3 medians. Wonderful. So let's speak about that again. Okay, so AF intersect with CE intersect with BD at one point. This point occurs at point of intersection of medians or point of centroid of medians. Okay, so let's take theorem about that. This example here. So M is point of concurrence of medians. So the point of concurrence of medians, its point divides the median into the ratio. Okay, ratio is equal 1 to 2. Yes, 1 to 2 from the vertex, from base, I'm sorry, and 2 to 1 from the vertex. Okay, as a drawing here. Okay, so from M to D it's 1, M to A it is 2. Wonderful. If I have something here like that, the point of concurrent of medians of triangle divides it, the median, into the ratio 1 to 2 from the base and 2 to 1 from the vertex. So let's take an example about that. So I have here AD, so I'm here at point of intersection of medians. So from M to D it's 1, and from A to M is 2. So AD, all of them is what? 1 plus 2 equal 3. So if I want to write the ratio here in triangle, if I have here number 1, if AD is 9 centimeter, so AD, all of them 9 centimeter. What about MD? MD equal how many from AD? Okay, so MD starting with MD. So MD equal what? From A to M, I'm sorry, from M to D it is 1, and AD is 3. So it's become 1 over 3. Yes, wonderful. How many centimeter? So if I have AD is 9, so 1 over 3 times 9, or 1 over 3 from 9, it's become 1 over 3 times 9, a third of 9. Yes, 9 divided 3, it's equal 3 centimeters. Yes, 1 over 3 from 9, it's become 3 centimeters. What about AM from AD? AM is 2 from 3. So it's equal 2 over 3 times 9. It's equal 6. Don't forget that. Okay, but give me attention here. In the opposite figure, we found that M here is centroid of medians. Okay, so complete MF equal how many from BF? Where is MF? MF here. Yes, MF here, the smallest, the smallest median here. Okay, or part of median, the smallest part of median. Okay, the ratio will be 1 to 2 again, so it's equal 1 from BF, all of them 3, so it's equal 1 over 3. What about AM? AM from AD. AM I come from vertex, so the ratio will be 2. And AD it will be what? 3. Yes, wonderful. So it's become 2 over 3 again. What about CM and ME? Where is CM? CM from vertex here. ME it's 2 base here. So the ratio will be what? 2 over 1. It's equal to. Other example for that? Yes. If CB is equal 10 centimeter, that's CB. All of them is 10 centimeter. What about BD? Oh wow. D here is midpoint. So BD equal. Yeah, that's correct. It's equal 5 centimeter. Wonderful. What else, mister? MF equal 3. From M to F is equal 3. What about FB? Oh wow. From M to F equal what? 3. What about MB, the first? MB equal what? Yes, that's correct. It's equal 6. What about FB equal what? From F to B, it's equal 3 and 6. It's become, yes, that's 9 here. Wonderful. What else, mister? CM equal 8. From C to M is equal 8. There's a greatest here from the vertex. So what about ME? ME is equal 4. So ME equal what? 4. So CF, all of them equal what? Yes, 8 plus 4 is equal 12. Yes, it's wonderful. More exercise about that. In triangle ABC, if D is midpoint of BC, then AD is equal what? It's called what? Yes, that's correct. It's called median. The number of medians of triangle is how many medians triangle? Yes, that's correct. 3 medians. The median of triangle intersect at, yes, 1 point. This point we get as what? Centroid. The point of concurrency of median, the centroid point of triangle, divides each median in the ratio blah 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 to blah 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 from the base. Oh wow, from the base. Do you remember that? From 1 to 2 or 2 to 1? Yes, that's correct. 1 to 2, that's correct. The point of concurrency of medians of triangle divides each median into ratio blah 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 to blah 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 from the vertex. Yes, that's correct. It's 2 to 1 from the vertex. Number 6. The point of intersection of median of triangle divides each of them with a ratio from the base. 2 to what? From the base, mister, from the base it's 1 to 2. But here starting with 2, yes. I said that before. The first one 1 and the second will be 2. If the first one take 2, what about the second? Yes, that's correct. It's become 4. Wonderful. The first here is median, the second here 3, and 1 point, 1 to 2 again, and here 2 to 1, and that's the result here. Okay, please take screenshot for that and write that in your book, inshallah. You will find everything will be very easy.